what water is, and we've talked about pumping theory and, in theory, how to pump water, right? Now we're going to talk about operating them. This might be the quickest chapter if I remember. Hopefully it is. It's 83 slides, maybe not. All right, making the fire pump operational begins after the apparatus is properly positioned and parked, right? Got the brakes set. Positioning is important in pumping, period, right? We want to get a three-sided view of the building, but then we don't want to pull so far that, you pull the extra 100 feet down. Now you got to calculate for that in friction loss, We want to be effective in positioning so we can effectively pump, but we also don't want to block the truck. So a little give and take. What two items must be used before pumps are operational? The air brake and the chocks. We normally don't chalk until, yeah, until maybe we got in pumps and we're flowing water, and then we got a couple lines off. Then we'll chalk it every time, Chief. All right, summarize facts about operating from the water tank. First thing we're going to do is use our onboard water tank, right? Even when we're connecting to a positive water supply, we've got 500 gallons on there, and that's typically we're going to get there, drop our tank, and I'm giving my tank water as we're hooking up to positive water. Cannot use the onboard tank as sole supply of water unless it's something small, a dumpster fire, car fire maybe. Again, we're going to begin with our onboard tank, then transition to an external tank if we're depleting that. When putting the pump in operation, the initial water source is often our apparatus tank on board. We're going to exit the cab, chalk the wheels, proceed to the pump panel. We're going to open up our tank to pump, open up your discharge that's being used, open your valves, increase the throttle pressure, dial in your pressure. Then once the hand line is open, the driver, operator may need to adjust the pressure. While the pump is in operation, the driver, operator has multiple responsibilities. Monitor all gauges and adjust the throttle. During fire attack, hose lines may operate intermittently and the pump may overheat. We all know how to stop that from happening or prolong that. We're going to open up our circulator or our bypass, and then we can also open up our our booster tank, drop the nozzle in there, circulate some water. Many methods to cool down your engine. It is necessary to transition to external water supply before depleting your onboard tank, right? If we get too low, and then we got the risk of cavitation. So you're about a quarter of the tank, you better be in positive water. We're going to connect supply hose to the appropriate pump intake, make the connection to the intake with a closed gate valve. We don't want to have it open, right, because then all our water in the tank is going to be going into our supply hose. Open up the bleeder valve on that gated intake and adjust the discharge pressure by using the throttle once we got positive water. Explain considerations when operating from a pressurized water supply. That's our hydrant or another pumper. Pumpers may operate from two basic pressurized water supply sources, a fire hydrant and again another pumper. Driver operators should be aware of changes in pump volume and pressure. As discharge volume from fire pump increases, incoming pressure from the water supply may drop. That's why we're always looking at that intake as we open up other lines. Pumping at low residual pressure while being supplied by other apparatus is dangerous. Maintain residual pressure of at least 20 psi on your master intake gauge and water supply system. Overtaxing systems may cause sediment and debris to loosen. Safety and firefighting needs to be taken into account when choosing a hydrant. Closest hydrant may not always be your best choice. To make an informed hydrant selection through knowledge of your water supply system is necessary. So we have our street and water exam that we do every year, right? And just from frequency of runs, you know, we're pretty familiar with our water district, and being downtown, you know, first district, second district, you know, you got a couple hydrants on each block. And now we can pull up on our iPads, really convenient. We can pull up our iPads, we got a water map, we can see where our hydrants are before we even get there. You know, as a sergeant though, you know, remember it's a great tool to have, but if the iPad's down, you know, we're looking down the block. You know, don't just get so reliant on that iPad to where we can't use some old school firefighting. Oh, shit, there goes some orange. There's a hydrant down there. Might have to skull drag, but you know, we'll get water. Hydrants served by large mains interconnected in grid pattern usually have less sediment and deterioration. We don't have to worry about any sediment in our hydrants. I've never seen anything. We do have some dead end mains. I think there's one in Portland for sure. I think on Northwestern, it's dead end main. You might have some issues there, but forward lay is the most common ways for a pumper to be supplied from a hydrant. Some departments use a four-way hydrant to aid in the purpose of making a forward lay. We do not do that. Connect valve to the hydrant, connect original supply line, open the hydrant, connect second pumper. We ain't gonna, each pumper's bringing in their own water. We don't use those. Making reverse lay to the hose is laid from the fire to the water source. So we used to do the reverse lay a lot when we were, you know, using our wives. We laid to common two-pumper reverse lay provides for an attack pumper and a water supply pumper. You know, you might have somebody finish your lay, or tell somebody to bring your water. Lively class going on next door. After connections to the hydrant are made by the driver operator, must take action before putting the pump into service. Close the tank to pump valve, read the pressure on the master intake, and record static pressure reading before pumping. Why would we close that tank to pump?
Because you get water from the hydrant.
You're getting water from the hydrant. You're in positive water at that point. Also, you know, if something happens with that, you know, say we have a main break because we got multiple pumpers on scene, multiple hydrants, you know, there could be a fluctuation. Happened to me once in Portland on Griffiths. We had a fire, water main collapsed. Then we don't have a supply. We got guys inside. I can go back to that tank to pump, and that gives them enough time to get at least out of that structure, right? So it's the reason why we close that tank to pump after we're in positive water.
If a water main breaks, like, is the first sign going to be like the less pressure coming into the apparatus, or is it going to be the water on the road?
It'd probably be the water on the road.
Yeah.
Because you'd have to be looking at that gauge exactly when that main breaks. So yeah, that this fire in particular, it was all of a sudden, you know, you see like water coming out of the street, and you're like, what the hell? And then all of a sudden you see the street start to, you're like, oh shit, water main break. Take these items into consideration before putting the pump into service. Running pump without water for a significant time may cause overheating or faster wear. If a hydrant is inoperable, disengage the pump drive system before relocating your apparatus. Again, don't want to try to put it in drive while you're still in pump, or switch over to your drive while you're in pump. You got to put it in neutral with that switch and drive. Pump panel. Make sure your pump panel is ready to operate with pump engaged and apparatus wheels chalked. When operating a two-stage pump, set transfer valve to proper position before increasing the throttle. Pump supplying relay operations or master streams require use of parallel setting on the transfer valve, right? Because we're already pumping over half of our rated capacity. Open all valves slowly, especially when using large diameter hose. Hose must be filled before pressure is established, right? We're not gonna just crank it up to 150 and then open up that discharge. You know, that dude's gonna be going for a ride. You could hurt somebody. Increase the RPM while observing your master intake and your discharges. Again, we don't want to go below 20 psi on our intake gauge, getting close to cavitation. There are several methods used to prevent the pump from overheating. Establish continuous minimum flow during intermittent use of water. Pull a length of booster line or another small diameter line and fasten to a sturdy object. Open the valve that supplies the booster and recirculate it that way. During prolonged pumping operations, bypass circulator may not provide sufficient cooling under some conditions, and additional measures are required. Several methods used to prevent the pump from overheating. Open up your discharge drain valves, so just open up those valves, let water circulate, or partially open your tank fill valve. The difference between static and residual pressure determines how much water, or how much more water the hydrant can supply. These are three different methods to determine how much more water you can flow: percentage method, first digit method, squaring the lines method. So your percentage method, percentage drop equals your static minus your residual times 100 divided by the static. Simple stuff, guys. We should all know this. The first digit method is a quick and easy way to calculate available water using PSI and GPM. So we're going to find the difference in PSI between our static and residual pressures, then multiply the first digit of static pressure by 1, 2, or 3 to determine how many additional lines of equal flow may be added. Squaring the lines method may be used to calculate how much more water hydrant can supply. So we're going to note the static pressure of the water system before any discharges are open. No usual static pressure in the water system under normal circumstances, and then we're going to determine additional amount of water available by squaring the number of lines currently flowing and multiply by the original pressure drop. They are. I don't know what Phil's teaching over there, but it must be a funny topic. Avoid water hammer and pressure surges when opening and shutting down lines, right? Water hammer is bad for the pumps. We got to take care of our pumps. Methods again, there's a percentage drop, squaring, and what's the other one? First digit method. All right, so next objective, summarize facts about operating from a static water supply source is going to be drafting. So for this we need hard intake hose and we'll be drafting from a static source. We're probably not going to do this on a fire scene. As water moves to the pump, additional pressure losses are encountered. The ability to overcome losses in pressure is limited to atmospheric pressure at sea level, which is 14.7. Nice. Indicators of cavitation, pressure gauge on the pump will fluctuate and hose streams may pulsate. Pump is going to make some noises like gravel's passing through it, you're going to know it. And lack of reaction on pressure gauge as you increase the throttle. Most important factor when selecting draft site is the amount of water available. Size of body of water, tidal volume, the depth of the strainer, and the water temperature can affect it. Type of and quality of water must be considered when drafting. Oh, damn it, I keep reading the headline, and it's the same on multiple slides. Non-potable water may be dangerous to the pump due to corrosion and deterioration. Accessibility to, damn, I did it again. Increase in the amount of lift required to reach the pump. So if I got to drop this hard suction down 30 feet versus 10 feet, it's gonna be harder to get that water all the way up there. Once a suitable drafting site is chosen, move the apparatus toward that position. That makes sense? We're going to place the apparatus directly at the location from which the intake may be deployed. Set our parking brake and chalk those wheels. And follow your local policies regarding placement of traffic control devices and warning lights. Use a rubber mallet. So this is how we're going to get that airtight seal. We're going to use a rubber mallet and tighten all the connections. Place each section of hose in line before coupling is turned. Fasten rope to the end of the strainer. That's important. Why do we want to do that? We want to keep, if it's shallow, we want to keep it off the bottom. Keep it from picking up any sediment and debris. When the pump has been made operational, priming the pump will begin the drafting operation. So, gonna throttle up, hit the primer. Water comes up. This guy is using that mallet to get those seals nice and tight to create that vacuum. Like I said, if those seals aren't tight, you're not gonna be able to create a vacuum in your pump. You have air escaping. Or more air is going to be coming in as you try to create the vacuum. Open drain valve, intake relief valves, gaskets on intake, hose couplings. Let's see, after successfully priming the pump, slowly increase your throttle before opening any discharges. So your throttle is going to determine how much GPMs you're throwing out. Air leaks on the intake side of the pump can cause us to lose our draft. Whirlpool allowing air to enter the pump, and air leakage due to defective pump packing. Strainer should be flow tested. Gradual increase in vacuum with no change in flow rate may indicate that a blockage is developing. Blockages often occurs after the pump has been operating at a high rate of discharge. In extreme cases, pump may go into cavitation because you're blocked, you're not getting anything in. It's going to run that pump empty. Attempt to clear the blockage and return to normal operation. Most common place to occur is in the strainer. It's going to be a big issue. To shut down during pump operations, slowly decrease the speed down, the engine speed to idle, take pump out of gear, allow pump to drain, remove all connections, and operate positive displacement primer. Anytime we draft, what are we going to do to our pumps? Backflow, right? Got to get all that stuff out. Next objective, describe actions for sprinkler and standpipe support. Driver operators are responsible for providing adequate support to the fixed fire suppression systems, automatic sprinklers, and standpipes. Sprinkler systems are designed to support a specific number of fire sprinklers based on fire hazard being protected. Sprinkler systems can be automatic water supply or supply augmented by the fire department. Installation of occupancies. Pre-incident planning, right? We do our target hazards, and then a bunch of our high-rise buildings that we respond to. We're always looking where our connections. If you make a run to somewhere you haven't been, you got time after, if it's a med run, take a walk around the building and familiarize yourself. Also, anytime you see new construction, right? We're all good at that. If we're driving by, we see, them building something every couple, weeks or something. We might stop by and see, okay, I see water shutoff's going to be there. Walk around the construction site. You see where stuff's going as it's going up. That way, you miss the day they do the walkthrough, you're still pretty familiar with it, right? Immediately supply the fire department connection where there is a fire with a sprinkler activation. First arriving or other first alarm engine company should locate the fire department connection and the nearest hydrant. If indication of a fire, connect appropriate hose lines, and pumper should establish water supply at the hydrant. Immediately supply the fire department connection. So confirm presence of actual fire conditions before pumper begins to flow to the fire department connection. Slowly develop amount of pressure required to supply the system. Guidelines. General guideline is to discharge 150 psi into the fire department connection. So 150, on sprinkler, you got your appliance, another 15 psi, then you got to find out what floor we're on, 5 psi per floor. Got a little cheat sheet in most of the pumpers, right? If you need some quick numbers, look at that sheet. And if they ask for more pressure, give it to them. Hopefully they realize there's a lot of them have the pressure reducing rod in there, that hopefully they're utilizing that too. That's, hey, we need more pressure. We'll try adjusting that on the inside. Firefighters should check sprinkler valves as soon as is practical to do so. Open and closed valves in most circumstances. And you're going to ensure stationary fire pump is operating if it supplies a sprinkler system. So, a lot of times in the power surge, you'll hear a dry system gone wet. You'll hear that sprinkler system, the compressor downstairs or whatever. Let's see, standpipe may be wet or dry. I always keep getting ahead of myself. Right when I say something, next slide pops up. So wet system, some contain water under pressure that may be used as soon as the hose line is stretched and the valve is open. A dry system must be charged with water from either the occupancy's water supply, stationary fire pump, or fire department pumper. Always support the fire department connection to ensure adequate flow of pressure is provided for firefighting operations. Anytime we have a fire in a high rise, we're connecting to the standpipe and the sprinkler. We're not just going to rely on that fire pump. Hose lays for use in sprinkler and standpipes. Pump discharge will depend on pressure loss, friction loss in the hose lay from the pumper to the fire department connection, friction loss in the hose on the fire floor, nozzle pressure and type of nozzle in use. What type of nozzle do we use on our high-rise packs? Selectable gallonage, and then we can always take that fog tip off, and then we got a smooth bore nozzle, right? Need 100 psi for effective fog nozzle, and how much? 50 PSI for a smooth bore. So if we got low pressure, we'll switch to that smooth bore. Do not use pump discharge pressure in excess of 185 unless standpipe system is designed to do so. Driver operators should be aware of considerations when operating standpipe systems. So when equipped with pressure reducing valve, there we go, elevation must be based on total height of standpipe or zone being used. If pressure at a particular valve is less than that for which the valve was adjusted, will result in inadequate pressure for attack lines. Vandals may tamper with valves in dry standpipe systems, so it's always a good idea to maybe flush those before you connect your hose to it. And when dry standpipe is charged, there will be time delay as water fills up the system and expels air, right? If we're on the 10th floor, we connect to that system, the water's got to rise all the way up. Many manual standpipe systems are designed to be pumped at a pressure of 150 psi. Let's see, some standpipe systems may require adaptation in order to be used, right? We've all opened up the sergeant's compartment and see all those different couplings, that's for, we can handle whatever we pull up on. Might need a double male, double female. Don't know until you get there, but we have the tools to make it work. I always thought of, being a lot of guys hated being being an engine sergeant because you're not going in no more. You're outside on the pump panel, but it's like one of the first times you get to think on the fire scene for yourself and just be a problem solver, figure out multiple ways to do multiple things. So if you like figuring stuff out, it can be a fun job. Explain actions taken when troubleshooting pumping operations. Case in point. Not everything's going to go to plan. You got to have a plan B and figure out how to take care of it. So be prepared to troubleshoot and correct issues that may arise during pumping operations. First thing we're going to do, immediately notify your incident command, and then trace the problem back to its source, right? We typically start back to square one. This thing's not pumping. Let me restart. Let me go make sure the parking brake's set it back in neutral, take it out of pumps, put it back in pumps. Go from there. Next objective is 7 through 13. These skills sheets can be found. Oh, I ain't doing no skill sheets. Oh, we're done. Wow.